My colleague, and we will share our presentations on today in the way that I do it now, and Willy does it in the afternoon.
I need a request. We need to make sure they have the microphone.
Okay, so then I guess I have to sit down, do I? If it is supposed to work nicely. Is that better now? Better now for you?
Stand up.
Is that all right?
Yeah.
Can I do that? Okay. Get rid of that chair. Okay. Mapping socio-ecological transitions and exploring links with employment. I will have 3 issues to deal with. One issue is that I will present some conceptual considerations concerning the meaning of socio-ecological transition, and I will bother you with what we call a biophysical perspective on the economy, which is not so common. But if you discuss the relation to the environment, this biophysical perspective, great. Oh, works? Fine. So that's pleasant. So this will be my first part. Second part will be on the global context of a European socio-ecological transition. I mean, we're not alone in the world, and sustainability is undividable globally, and the role of the European Union will strongly depend on what happens on the rest of the globe. So that's my second point I will address. And the third, I have to be a little bit humble. I will discuss socio-ecological transitions and labor. I'll show you some of the very preliminary approaches we took to that issue. But there, I really hope that in the interaction process, a lot more will develop. So, my first part, some basic conceptual considerations. So, what is a transition? If we look at the literature, we find a strong scale dependency of the meaning of this word, transition. We have sustainability transition on the scale of the grand socio-metabolic regimes in human history. So this is an approach we will try to take in this project. We may have it on the scale of a Kondratiev cycle, so that's a more 60, 80 years kind of scale. And we even may have it on a much more gradual scale of improving resource efficiency, decoupling resource use from economic growth, so that's on a more incremental, small scale level. Okay, another important conceptual issue is what is the core process in a socio-ecological transition? And we think, and I will try to explain to you, that it really has to do with the change in source of energy, in energy density, in energy cost, in available energy amounts. So even if this doesn't shine through all processes, this is the core process in a transition, also in the transition that might be a sustainability transition for Europe in the future. So next issue, what drives it? Is this an evolutionary process that happens by itself? Is that driven by resource scarcity? We run out of things. Is it driven by voluntary policy action? Here we won't take sides. You see in the outline that both variants of voluntary action and a kind of evolutionary process will be considered. Yeah, and finally, in which world context does it take place? Is traditional development ongoing? Is the next natural context stable, or are grand cycles destabilized? So that's important. That's the typical Dutch, if I may say, picture of a formal transition. So we have a proto-development, we have a takeoff, an acceleration, a stabilization, and whatever you put on the 2 axes, to the right it's time, and to this, in the vertical you can have various things. What is socio-ecological about it? So, key is that it is a structural transformation not just of society, but of the patterns that link society and environment. And that's what makes me talk about a lot of biophysical processes. It's a transformation of society's energetic and material metabolism, which I will empirically show a little bit to you. And it induces a structural change in the natural systems that society uses or that are affected by society, be it the climate, be it the soil, be it the biosphere, whatever. And a transition, if we use the highest scale I was talking about, between socio-ecological regimes. And this, what is the regime idea? It's a little bit different to the Dutch approach. If we really put it on that very high scale level, we may talk about 3 major regimes in human history. So one is hunters and gatherers. We had that for 1 million years, a lot of time. And we had a major transition, the Neolithic Revolution, that occurred in many places at different times. But it was always a major qualitative transition, not just an evolutionary change. Then we had agrarian societies, and we had an industrial revolution that was also spread out across many centuries. Didn't happen all at once, but it caused major structural change. And we believe, that's kind of a key claim in this project, that a sustainability transition in the end is on a par in its structural importance with these major transitions in human history. A little bit of an illustration. Well, so mine isn't set. I have a big, I'm trying to entertain you long enough. Fine. So I'll show you the transition for the UK. UK was the first country to make this industrial transformation, this transition from an agricultural, agrarian society to an industrial society. And that started in, well, 1700 starts this scale. It started even earlier. The key of this process, according to my claim, and this is what this figure says, is a transition in source of energy, which you see here. So first it was almost 100% biomass. This is usually not recognized as an energy base of a society, but it ought to be, by first coal, and then next oil and gas. And as this, in the vertical there's proportions, it really looks like these beautiful transitions that are very schematic. The same thing happened, of course, and happens in the rest of the world. So here we have 2 latecomers, just to compare, Austria and Japan. Austria started the transition 200 years later, Japan 250 years later. You have the same processes, not so nicely smooth, but you have the same thing happening in a much shorter time and ending up pretty much the same. And you can show these very graphs for many, many countries of the world, and for some, this is still in a beginning. The uncomfortable thing about historical transitions is that they not only induced a qualitative transition between energy sources, but they induced a huge quantitative transition. If we look at the energy use for one human being per year, in the agrarian regime, we needed about 40 to 70 gigajoule to sustain a human, to get a human through the year. In the industrial regime, we need 150 to 400 gigajoules to get a person through the year. We could put the hunters and gatherers ahead. That would be, again, 1/3, 1/4 of the agrarian pattern. The same is true for materials. The same, of course, for population density. But the trouble is, if we look at the impact of this enhanced use of energy and materials upon the environment, so a very crude indicator is just impact per hectare or energy per hectare, anthropogenic energy use per hectare or tons of materials used per hectare, you see a 10 to 30-fold increase per human being on that earth. And so we have not only increased the human beings, we have increased the impact of human beings very, very substantially. And the next transition cannot just prolong this pattern. So we can't jump another 3 times per human being in use of the environment. This is impossible. We have to not only change from the last pattern to the next, but we have to change from the course of human history. So that's quite a challenge. Well, let's have a quick look at the composition of the industrial metabolism in Europe, for example. So what you see, what is the material input to European society? So it's per capita 17 tons. It consists 50% about of energy carriers. This is biomass, and this is fossil fuels. And the other 50% consists, well, to a large amount of construction minerals, so sand, gravel, things like this, cement, and a small fraction of industrial minerals. The trouble is, this contains carbon. So 50% of our metabolic input is carbon containing. If we look at on the output side, if you look at these small slices of this cake, you see air emissions, you see waste, you see emissions into water, and you see dissipative uses of material like fertilizer or salt in winter. But the huge, big part is CO2. So decarbonization is not a minor change in our metabolism, it's a major change. And we may say some of this CO2 is carbon neutral because plants digest it again. But the discussion of carbon neutrality of biomass use is a long discussion. Okay, if we look at this in the maybe more common terms of the material cycle or in terms of life cycle thinking, here you see we have resource extraction here in the left corner. We extract energy materials and non-energy containing materials, that's the blue and the yellow, and then we cycle them through to consumption and use. Here we end up with 10% of what we had before. And here we go. And infrastructure is a big place where we put our stuff. We put particularly our material, our non-energy materials. And recycling are very, very small flows compared to the huge input. So we cannot recycle ourselves into sustainability, although these flows are very important. And the flows that you see going off is CO2. And this is about proportional to what is happening now in Europe. Okay. So this was a very short briefing on how socio-metabolic thinking goes and how we analyze transitions between socio-metabolic regimes on this very high scale level. Now I will go into the second part. So in what global context is the next 15-year future or even longer of Europe? How is it positioned there? A few generalizations. So one is we have an exponential rise in the annual extraction of raw materials from nature worldwide. I'll immediately show you the numbers. We have changed our metabolism from renewables to ever more non-renewables. I'll show you. There are analyses on what drives this increasing extraction of materials and energy carriers. And we may say it's driven by population growth. That has an elasticity of 1. So that's a very strong driver. By what we call development, because what we have as development in the world is more or less emulating traditional industrial patterns. So it's emulating the industrial transformation that European countries have had in their past income. And as a mitigating variable, population density. This is structured into phases as a result of multiple transitions. They are not simultaneous. They take place in sequences in various areas of the world. And finally, I will show you a little bit of the material of the United Nations International Resource Panel that will publish its materials on Monday in Geneva. So I'm not sure that this is okay, that I show you some of the numbers today already, but this will come out on Monday and gives you, I think, a quite good picture on the role of Europe within a world. So that's socio-metabolic scale of the past century. You see the global commercial energy extraction or supply, that's the same on the global level because trade equals out, has increased tenfold. And this is not accumulative, this is extraction each year. The same is true for materials, not as widely as with energy. So materials are usually aggregated in these big classes. You can break it down to a lot of detail. Of biomass, fossil fuels, minerals and metals, and these construction minerals I was talking about, you have an 8-fold increase over the past century. Annual extraction. This is the composition, what I said before. We are getting, 100 years ago, we had almost 80% renewables in our metabolism. Now we have 30% renewables in our metabolism. And all the unrenewables are increasing. So the old rules, don't use, try to stay with renewables is absolutely not what is happening. Okay. Now I take a next step. I'm not trying to sort of point disasters on the wall, but I'm trying to show you for our future analysis in the project that one has to really think about and deal with structural change that's actually happening, that has been happening in the past, and that we have to be able to make scenarios on, to model, to fantasize, to envision for the future. Otherwise, the idea of socio-metabolic or socio-ecological transitions will remain empty. So I show you now the per capita metabolism over the past 100 years again, globally. There you see that looks much less frightening than the figures we had before. You have this nice red line, which is our income. But you can see the income increases much more than our use of materials, so we're getting monetarily, in real terms, much richer than we are getting voluminous in terms of materials. And you see an interesting phasing, and I will go into this in more detail. The main message here is we have a long-term decoupling process between our wealth, in terms of income, and our material use. And this is a good news, and this is an important issue to follow up with. Second driver, here we have eliminated the driver population, and then you see it's much flatter than it used to be. I look at the other driver, which is not a very good figure. It's the relation between income and material use, or we could just as well put energy use there. It's a log-log scale. What you here have per capita income at constant dollars, and here you have material use per capita, and you have quite a strong correlation over 175 countries. But you see it is scattered. It is not a really tight correlation. So there is room to maneuver. This figure says the same,